Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today, we will continue the use of graphics masks in creating game maps. This was our application at the end of the last video. We have a hexagonal map on which there are three flashing icons. One for the landing zone, one for the pickup zone, and one for the target zone. And each of these icons can be turned on or off by ticking the small tick box on the right hand side of the dialog. Each hexagon is a different colour and a different letter, indicating what kind of terrain it is. The green hexagons are those which are mainly flat or flattish ground with grasslands and no obstacles. The grey hexagons are the urban areas. The light blue hexagons are rivers or water areas. And the E hexagons are the small hills or large mountains. What we're going to do today to expand on this is to position buildings on the map by adding an extra graphic and a graphics mask. So right at the beginning of the code, where we set up the maximum size of the grid, we're going to set the maximum number of buildings. So for the moment, we'll set a maximum number of buildings of 10. Now each building will obviously need a location on the map, and it will need a state of the building itself. So further down the code, where we set up the enumerations for the terrain, we're going to put in some information for the buildings. So we're going to set a type up called UDT building, and this will contain an X and a Y coordinate, and additionally a Z coordinate, because we'll want possibly more than one building per urban area. And the final element of this UDT is state, and this is to tell us what state the building is currently in. And we will create another enumeration to handle the state variable. So our building can either be fully operational, in other words active, it can be damaged, or it can be destroyed. And we'll need somewhere to put all this information, so we're going to create an array as an array of user-defined types. This will be a global array to store all the buildings information, and each element in the array will have the UDT building structure within it. So we'll store the X and Y coordinates, which will tell us which hex it's on. We'll have the Z, which will tell us the offset, which part of the hex it's on, and we'll have the state to tell us which of the three states the building is currently in. So now that we have that information, we'll actually have to generate our buildings. Now, as you remember from the last video, we did this in the initialization of the dialog. So if we go to the event handler, the callback function of the dialog, we'll see in here, this is where we created the random terrain, the graphics map, and set the three icons for pickup, landing zone, and target zone. We'll want to do something remarkably similar for the buildings. So we'll create a new function called setBuildings. This will take two parameters, the first being the dialog handle, and the second will either be a true or a false. If the second parameter is true, it means we want to create the buildings. If it is false, we just want to redisplay them on the screen. So let's create this new function. So here's our new function with its two parameters, the dialog handle and the true or false, which is the redo function to know whether we want to create the buildings from scratch or whether we just want to position them on the map. Now for reference, we'll want to put in a piece of text just to remind us what the user-defined type we're going to be populating is going to look like. And we'll want a simple for next loop to go from number 1 to the maximum number of buildings. Now we're going to need some local variables with this to keep track of which hex we're on, which building we're dealing with, and the offsets. So we'll create these up at the top. And since we're going to be doing almost exactly the same thing with the bitmaps and the bitmap masks, we need all the variables we used for those. So we will create them as well. So the first thing we want to test is to see whether the second parameter is going to be true or false. So if this is true, we want to generate the building information and save it into the array. So we will firstly generate our target building, which is the building sitting on the target hex, which the troopers are going to attack. Now, since we know the target zone location, it sits inside its own user-defined type, we can pick up the long R and long C locations from the target zone. What we don't know is what the offset is. Which area of the hex is this building going to be located on? Now, there are going to be a maximum of 6 buildings per hex. So all we need is a random number generator to generate a number between 1 and 6. Very easy to do. Now, before we go further, we'll need to redimension the array for the maximum number of buildings. So that handles the very first building. We now have to handle each of the other buildings which are not on the target zone. So for these other buildings, we're going to have to work out which terrain they're on and which position, so that no two buildings will occupy the same space. So we're going to use a little true-false variable. So in order to know where this next building is going to be located, we first have to find an urban area on which to put it. And we have to make sure that that urban area does not have more than 6 buildings already on it. So we'll do this within a while loop. And this while loop will continue to run until found equals true. Now, with all these kinds of while loops, you have to make sure you don't end up with an infinite loop. So we're going to create a brand new function, which we'll create in a moment, whose job it is to find the suitable terrain in which this building is going to sit. And we'll call that function find terrain. Now, we're looking specifically for a buildings location. This is an urban area in which we can actually position our building. And we will get back out from this function the long R and the long C coordinates of that particular hex. So if this does return a true value, we'll want to find out, is there any space left on this hex for an additional building? Because each of our hexes can only store 6 buildings. So we'll need to use a new function to find building space, giving it 3 parameters: the long R, the long C, which have been returned by this find terrain function up here, and as an output from the find buildings, it will return the slot into which this building is actually going to sit, between 1 and 6. We'll come back in a moment to actually create these functions, but we'll finish off the logic in the area of the code we're actually in at the moment. So once we've come out of this loop and out of the endif, we will then have 3 values populated: the x and y coordinates and the offset as well. So we'll need to store that information inside our array. And we're going to use the prefix command to save a little bit of typing here. So storing within the buildings array and the element which is pointed to by long B, and we can then populate the 4 values within the user-defined type. The x coordinate, which is long R, the y coordinate, which is long C, and the offset, which is long Z. And for every new building we create, the condition, the state of the building, will be active, fully operational. And our else condition will be to use the stored locations of the building. The else, as you'll remember, is when we're just redrawing them on the screen. So we'll just populate our 3 coordinates from the buildings array: the x, the y, and the z coordinates. So now that we have the x and y coordinates and the offset all set up, ready to display our icon on the screen, we need to know exactly where on the screen this is going to appear. Now, when we positioned the icons before, we positioned it in the absolute center of the hex. Now, since we have a maximum of 6 buildings per hex, we want to place them at each of the sides of the hex so that they don't overwrite each other. So we're going to have to work out the offset location based on the value of long Z, which is between 1 and 6. So we can do this in a select statement. The select statement will basically allow each of our offsets to be set as an offset for the x and the y coordinate, dependent on the value of long z. So having set all these offsets, we should now be ready to position the icons on the screen. Eventually we're going to have 3 icons for a building to show the different states. One for fully operational, one for damaged, and one for destroyed. I've only created the fully operational icon so far, but we want to put something in the code here as a hook into which we can actually build the 2 other icons when they're ready. So the next thing to do is to work out the state of the building to determine which icon to use. And again, another select case statement will do that quite nicely. So based on the state of the building, which if it is active, we'll know the building is operational, and we want to pick the building mask and the building bitmap. Now we don't have icons for the other 2 states at the moment, but we will put the case statements in to be ready when we do actually have them. So there we have 2 additional case statements, one for damaged and one for destroyed. Now having got this far, the next bit is fairly straightforward. We need to get the details of the bitmap just as we did before, by reading the bitmap and checking 2 values for the width and the height of the bitmap. Having got that, we want to load both the bitmap and the bitmap mask using the bitmap load command, and then we can work out the actual x and y locations on the screen using the same logic we did for the other icons. The only difference being we're actually using an x and a y offset to position our building at one of the sides of the hex. And then the final piece of work to display it on the screen will be to copy the bitmap and the bitmap mask onto the graphics control. Exactly the same as we did with all the other icons. And then at the very end of the routine, we'll want to redraw the graphic so that the user can actually see it. And we will free up the graphic bitmap at the end of the function. So that's quite a lot of code in there, but now we have to double back and look at the 2 functions that we'll need to create to work out which location to actually place the buildings on. That was the find terrain function and the find building space function. So we'll do the find terrain first. So this new function takes 3 parameters. The terrain type we're actually looking for, and 2 outputs, basically being the x and the y coordinates. So we'll need 3 local variables just to keep track of what we're doing, and we need to have another loop here, another while loop, and we'll use the long found to determine whether we've actually found the terrain we're looking for or not. Now we're doing it this way because we want to use a random number generator to actually give us a fairly random location for these. So the location for long R and long C are determined between 1 and the maximum size of our grid. And then we'll check to see if that particular location is of the terrain type we're after. So if the terrain value is equal to the terrain type we're actually looking for, then we'll mark it as found. If we mark the found as true, then we will exit from this loop and go on to the next line of code. Again, you have to watch that we don't end up in an infinite loop looking for some kind of terrain that doesn't exist. However, if we do actually find it, then we can set our output variables equal to long R and long C and mark the whole function as being true. So that's our first function created to find the terrain. The next one is to find the building space. So this function again takes 3 parameters. The long R, long C, and the output being the offset. The long R and the long C are indeed the x and y coordinates, specifying the terrain hex we're looking at. And the output from this is a number between 1 and 6, which is the offset, which side of the hex that the building is actually going to be positioned on. So we need to check all of the buildings, so we need to have a variable and a for next loop to keep track of that. So since we're going to be looking at the UDT again, it's worth actually just pasting it in this text so we know what we're talking about. Now, since there are 6 slots on each hex for buildings, we want something to keep track of those which are currently populated. So we're going to create a couple more variables. One for building slots, which are initially all going to be 0, as in there is no building at the first slot, and no building at the 6th slot, and none in between. And we'll use our favourite variable, long found, to keep track of which ones we've actually found. So this will be a simple for next loop to loop around all the buildings to see what's been populated so far. So for buildings equal 1 to the maximum number of buildings. Now we can test the value of the x and y coordinates of each building to see if it matches the hex we're actually looking for. So in order to determine whether there are any free slots on the hex that we're interested in, we have to sweep through the buildings array to discover which buildings are actually on that hex. And if they are, we'll record the position they're currently at. We can do that by populating our building slots variable. The $, function is particularly useful for that. You can use $, point it towards our building slots, which at the moment should have all zeros in it, and then whatever slot this building is in, pointed to by the Z variable. For one character, we're setting the value to 1. So if that particular building is in slot 1, then the first digit of the building slots variable will become 1. So by the time we sweep through all the buildings, we will have the building slots variable populated with values. Then all we need to do is to find if there's a free slot. So if we find any buildings actually on that urban area, we'll want to set the long found variable to say we've actually found one. So we'll set that to true. And after we've been through all the buildings, if the value is false, then we couldn't find anything. So long found will be true if we've actually found at least one building on the hex location that we're interested in. If long found is false, then we found no buildings at all. So if there are no buildings, it means we can quite happily go ahead and populate it. So if there are no buildings, we'll just slot in slot 1. So if we have found some buildings, we want to find which slots are actually free. And we can quite happily use a little for next loop to work that out. And again, the $, function again is very useful for that. So we're looking at the building slots variable to see if one element of that, pointed to by long B, is actually 0. If it's 0, then that's fine, we've actually found one. Then we can return function equals true and exit the function at this point. If we get to the end and we can't find one which is 0, which would mean that the maximum number of buildings were already populated on that hex. So at that point, we'll just want to say, no, we can't use this one, and we'll return 0 and false. So let's try a quick compile and see if we've missed anything, which we don't appear to have done. So having populated all this information, we'll then want to make sure it gets displayed correctly. So to finish off, we'll want to look back at our callback function, our event handler, and we can see that when the dialog is initialized, we're setting up the locations of the buildings. Now in our timer, we have a piece of code which will then display each of the icons we're interested in. So we'll need to copy this line of code down in here, and we'll change this to false because we want to display rather than regenerate. And if we try running this now, we'll see that we're now getting buildings appearing on our map. They are, however, flashing. We probably don't want the buildings to flash, and we want the buildings to remain on screen after the flashing stops. So when we put the terrain map back into place at the end of the timer, we'll want to display our graphics again. So what we'll want to do is we'll copy that line of code, and we'll put that one down there. And in order to make sure that it doesn't flash, we'll also copy the line of code in here so that when the graphic is actually put back on the screen, the buildings are redrawn at the same time. So we try running our code now. We'll see that our buildings are actually on screen. They're all appearing in urban areas, including a building on the target zone, and they're remaining on screen after all the icons stop flashing. And there should indeed be 10 buildings on the screen. 10 buildings. So if we increase the number of buildings, just to see if our clustering of buildings is working correctly, if we push that up to say 30 buildings, so we can see that our buildings are actually clustering quite nicely on the urban areas. And in fact, on our target area, we actually have a maximum of 6 buildings. So we now have a way of placing buildings on our map. And the same kind of approach would work for any other type of icon you want to display. In our next video, we'll look at placing our game pieces on the map. But that's it for today. Thank you for watching.